Shall we start, sir?
Yeah, you can start. Yeah. Please confirm that whether he is available there. Dr. Prayas is there.
Yes, sir. Video showing. Good morning, Dr. Prayas, sir. Is we audible to you?
Am I audible to you?
Sir, your sound is low.
Am I audible?
Yes, sir. Now it's perfect.
Right. Good. Thank you.
A very good morning to all of you. I Harpreet, research scholar from Department of Mathematics and Statistics, Central University of Punjab, Bathinda, India. Welcome you all on behalf of Organizing Committee of FDP in fifth day of 2-week faculty development program on data science and scientific computing. I hope you have been gaining valuable insight and experience throughout the journey.
Our today's session is taken by Dr. Prayas Sharma, sir, from Department of Statistics, Babasaheb Bhimrao Ambedkar University, Lucknow, India, on the topic of Introduction to Machine Learning. Before starting our today technical session, we would like to invite today chairperson Dr. R.S. Gupta, sir, University School of Basic and Applied Sciences, Guru Gobind Singh, Indraprasth University, for formal introduction of our resource person. Over to you, sir. Over to you, sir, Dr. R.S. Gupta, sir. I think due to technical session, Dr. R.S. Gupta, sir, not available here. So on the behalf of our today chairperson, Dr. R.S. Gupta, sir, I would like to invite Dr. Deep Singh, sir, to introduce our today resource person. Over to you, sir. Sir, you are not audible. Please unmute yourself.
Yeah. Thank you, Jatinji.
Thank you, sir.
Thank you, sir.
Thank you, Kaur. Good morning to all of you. I think Dr. R.S. Gupta from IP University, Delhi could not join us. So, with the permission of organizing committee, let me introduce today's speaker, Dr. Prayas Sharma from BBAU, Lucknow. So, Dr. Prayas Sharma is currently working as assistant professor in Department of Statistics, Babasaheb Bhimrao Ambedkar University, Lucknow. Dr. Sharma holds a bachelor degree in computer science and statistics, master and doctoral degree in statistics from Banaras Hindu University, Varanasi. He has qualified National Eligibility Test and obtained the Junior Research and Senior Research Fellowship from UGC India. Dr. Sharma is certified virtual teacher by University of California, Irvine. Dr. Sharma has not only a good knowledge of statistics and research methodology, but also has a strong computational and programming skills. He has more than 10 years of academic experience, both in the domain of teaching and research. He has worked earlier with reputed institutions, Indian Institute of Management, IIM Sirmaur, Gatisakti University, formerly known as National Rail and Transportation Institute, Dehradun, I think, Vadodara, University of Petroleum and Energy Studies, Dehradun. His research interest includes survey sampling, estimation procedures using auxiliary information and measurement errors, predictive modeling, business analytics, and operational research. Dr. Sharma has published more than 40 research papers in reputed national and international journals, along with one book and 2 chapters in book internationally published. He has more than 500 citations with H-index 15 and I-index of 17. Dr. Sharma has a keen interest in reading, writing, and publishing. He is serving seven reputed journals as editor or associate editors, and more than 30 journals are as a reviewer. and reviewed more than 150 research papers from the journals like Communication in Statistics, T&F, Taylor and Francis, I think, Journal of Statistical Theory and Practices, same, Taylor and Francis, Clinical Epidemiology, and Global Health elsewhere. Some other journal of mathematics and statistics, Statistics in Transition, International Journal of Applied and Computational Mathematics, Springer, International Journal of Productivity and Performance Management, Emerald, and Benchmarking, Emerald, Pakistan Journal of Statistics and Operation Research, to name a few. Dr. Sharma has attended more than 30 conferences, seminars, workshops, FDP, and organized three organized there a national level. Okay, Dr. Sharma has delivered more than 15 invited talks on various topics related to statistics, operational research, and research methodology, business analytics, and machine learning, etc., at different institutions and universities. He has also conducted training sessions for executives from aviation, medical and energy sectors, IOCL, HPCL, etc. Dr. Sharma received many awards and prizes for his meaningful contribution and dedication toward research and development, which includes International Travel Award by Uttarakhand State Council for Science and Technology, UCOST, and Outstanding Reviewer Award, Best Researcher Award, and Research Award from Honorable Vice Chancellor of UPES. At UPES, Dr. Sharma played an important role in stabilizing in the business analytics both at master and bachelor level, and served as coordinator of MBA, Business Analytics, and BBA, Analytics and Big Data. So with this brief introduction of Dr. Prayas Sharma, now I would like to invite Dr. Prayas Sharma for a second ahead. Dr. Sharma, over to you.
Thank you, sir. Thank you for such a detailed introductions. And I would also like to thanks to Dr. Meher for giving me this opportunity to interact with these learned participants. And I believe this is not a, only the discussions or the lecture which will be delivered to the participants here. Rather, I would also interact with the participant and try to enhance my knowledge, try to get the new things from there. Because, I'm always interested to interact with these learned minds and, to enhance the knowledge based on the discussions, based on the interactions with those participants. So thank you everyone. Thank you the organizing committees of this conference. And I would also like to mention here that I could get the feedbacks from few of the participants to whom I am personally, known to me. And this is one of the best FDP so far is going on with your efforts, lots of efforts and this project. So I would also like to thank to the organizers for thinking on these directions and giving this opportunity to the participants. Now we'll move on this topic of today's given to me, that is introduction to the machine learning. So here we will, in the today's session, we will like to discuss what is the machine learning, what does it mean when we say the machine learning, and what do we understand when someone says that we have applied the machine learning, we are using the machine learning, etc., etc. Machine learning, artificial intelligence, deep learning, etc. These terms we listen on day-to-day basis. And not only we listen these terms, rather in our day-to-day practices, day-to-day life now, these things are involved and moving around us. Maybe sometimes we can, understand, sometimes we can rectify that these are the machine learning applications, these are the machine learning algorithms. Maybe sometimes we are not. But majority of the thing right from the beginning, when we wake up and to the sleep, we do use the gadgets which use the applications of the machine learning, or we ourselves use the gadgets which are based on the machine learning, right? So if we talk about the basics of this machine learning algorithm or any such algorithm which is based on the data, right? And if you think on this the whole aspects of this machine learning on a philosophical level, you will able to understand that this is nothing a new things. Rather, you may say it's a new packaging, right, in the old tools and techniques. So we, at the philosophical level, you may say that machine learning is a new packaging of the old tools and techniques related to the mathematics, statistics, and with packaging of the some applications, some advantages of the computer science. So if you start with respect to the data, now Google has become a verb. That means we use everything in every sentence, in every search, we use the Google, right? And even sometimes when we don't know, behind the screen, behind the program, behind the applications, the systems are using the Google. So 3.5 billion searches query every days on this Google platform. 2.5 2.5 quintillion bytes of the data are produced by us every day. That means 10 to the power, 18 zeros in the small scale. So when we talk about million, then billion, and then after that, after a few steps, it comes to the quintillion. So that is 18 zeros. When I say 2.5 is 25 and then 70 zero comes in. You may understand how much data we are generating. And lots of this data or majority of this data rather, we are generating in the last 2 3 years, that we have created those data. And this might not be platform to talk about this, but the data which we generate is the only uh, the cause of happening the possible things, and also the things which is not correct, like the fraud or hacking or etc., that is also because of the data which we generate and which we share with the other platforms anyways. So every day, we get around 250 billions of emails, right, that altogether, and 45% of them are the spam. And you will notice that majority of this spam you're not getting into the your inbox, rather it directly goes to the spam, right? What has to be done to reduce this? You have to unsubscribe the ads and similar things before you go to any of the sites, because unknowingly you know we subscribe along with the other downloads, along with the other searches. We unknowingly subscribe many of the things which gives you the information about the product, etc., so you can unsubscribe them to reduce your. So the whole things about talking of this, that we are generating a lots of data, and what to do with all these data, right? And this is the basic foundation about the machine learning, that the data, as much data you will use uh, into your model building, right, that much, that much your model will be strengthened to give you the better and better understanding about the phenomenon along with the better prediction or forecasting. So when we start any of the, any such discussions about the machine learning, AI, deep learning, etc., we say that majority of the times we say that artificial intelligence is a broader umbrella under which there are the algorithm which segregate the machine learning and the deep learning, right? Uh, Almost true, almost right. Agreed with that, right? But to an extent, when you see with a very specific lenses, you will able to understand it's not completely the subset of the AIs. Rather, yes, definitely some of the things, techniques, tools are overlapping around the deep learning and machine learning, and there might be the cause when someone says that it can be the subsets of these signal. Whereas when we say the AI, it's a non-biological system that is intelligent through the rules, right? Through the rules. Please understand, please mind these rules. Because when you use the other algorithm, other sets of things, right? Like machine learning, right? So machine learning is the algorithm that learns model representations from data, right? They establish the rules, they establish the understanding through the data, right? There is no, you may say, the logical and mathematical rules, right? Rather, whatever it understands from the data, that becomes the machine learning models and later on can be used. Whereas the deep learning is basically based on the multi-layer neural network that can be used with the help of the weights on the multiple layers of the neural network, right? So the only thing is that how much you are able to give the weights on the different layers, different neurals, right? Which creates a network. So if your weights are very, very correct on the different layers of the neurons, right? Then definitely your model is going to be the best, right? And those weights are coming from the past experience. So when you say the past experience, means the past data, right? So this all scenario, as far as deep learning and machine learning is talked about, based on the past data. So as a human, we take decisions based on the past data, right? So if we take admissions into the IIMs, perhaps we can get a better job, perhaps we can get knowledge from the better professors, etc., right? So these are the past data perceptions. Similarly, we have certain perceptions, right? So uh, you know, if you can board the flight, you can reach to the different city comparatively earlier than the trains or any other mode of transportations, right? So, okay. So, based on the past data, past experience, we take the decisions. And similarly, we want to enable our machines to take the decision based on it. So it can learn from the past data and then it can take the decision based on the past experiences. Now, as I said, that these past experiences, as much experiences you have, let's suppose you have the experiences of the 10 people and when you have the experiences of the 1,000 people, right? Obviously, the 1,000 people experiences are much better than as compared to the 10. And there is the role of the data. So in this sense, we say that the larger the data we have, right, better is the prediction. Because these rules are only, or these models are totally based on the data. They don't have any rules behind that, any specific logic behind that. Rather, they specifically based on the data. And even as a human, as a programmer, as a statistician, whatever you say, we also want this machine to be specifically enabled based on the data, right? So that it can be self-learning procedure. So as much data you fit to the machine, fit to the model, that much model would be strengthened and give you the better and better information or idea about the future forecasting or whatever you say, right? So in the rough languages, you can say the art of science of designing an adaptive algorithm is the machine learning. So you're seeing on your slide, the left-hand side is the non-adaptive algorithm where you can use the just sorting, right? So numbers are given and you have to sort in the descending order, right? Whereas the right-hand side is an adaptive algorithm, and maybe you are aware with these characters, Doraemon, Nobita, Shinchan, right? So here the algorithm is the recommendation is given a person Nobitas and an item, short item in descending order of how much Nobita likes to them. So based on the different persons, when you are going to arrange something, that is the recommendation, right? And this is an adaptive algorithm which can be further used in the machine learning procedures. We'll discuss the types of machine learning and etc. in the later slides, right? Before that, may I know from you, any one of you, from that if we discuss about the data and the model, can you tell me which comes first? What do you think that which comes first, data or the model?
Data.
Data, right, right, absolutely. So that means the data. Okay, so data comes first. That's what you're saying. Anybody else? Generally people say that the data comes first, but I would tell you that the model comes first, right? How? You may have this question, how? Because whatever data is being generated, right, that governed by any of the models behind the screen, which is generally not available or we are not aware. So what we do with the help of the data, we try to establish that model which is already existing, but maybe we are not aware of it, right? So we are trying to build those models with the help of the data, right? So that if something follows in this manner, in this direction, we can have the another data sets, another behavior of the model on the long run, right? So if, please understand, we are not making the model, rather than we are always trying to estimate the model, right? And the aim is to make the differences very, very less, which we usually call it as error. So the aim is to make the errors very, very less in with comparison to the original model, which we are not aware of it, and the estimated model which we have prepared, right? And therefore, there are always some of the errors in the model, right? So usually if I talk in terms of the statistics, you run the model, you check the R square, then you check the, other things, and you got to know that your model is 90% accurate, 99% accurate, 95% accurate, etc., etc., right? So this differences between the of 5%, 4%, 1%, 2%, whatever you say, is the error in the actual model and the model which you have prepared, right? Any question, any doubt?
Participants, if you have any kind of inquiry or doubts, then you unmute yourself or put your question on chat box.
Yeah, please feel free, right? Maybe you have some of the valid points. Maybe you would like to add something to this discussion. That will be really, much better. I always believe in, in the uh, interactive sessions rather than the one-way sessions where I just, just show some slides and tell you something like that. Okay, fine. I believe so far there is no question. So when you say the machine learning algorithm
Sir,
means, yeah, please,
there is a
please.
question in the chat box. There is a question in the chat box asked by some participant. Please read that question.
Okay, just give me a moment. Does this means the data is used to detect unidentified models, identify the models and use the data to identify similar or different models in future, and possibly know which models to expect in future, making predictions in future and what to do with future? uh, uh, I'm not very clear with the questions, but as far as I understand, you are in continuations to the discussions of the data and model you are saying. So definitely, see, for example, we use the regression, right? All of us are familiar with the word regressions, I believe. And regression means what? The literal meaning of the regression is the stepping back. Why do we call it as stepping back? And regression is treated as the very, very good techniques for the making the models. So that's why we are saying that is stepping back, because from data we are trying to build the model, right? From data we are trying to build the model, and model is always there. So whenever, if you remember, in the regressions, when you write the, you know beta 0 plus beta 1 hat plus, sorry, x and plus epsilon. So these are the estimated values which you numerically or mathematically establish with the help of the least square method and etc. You try to estimate these coefficients, and based on these coefficients, now your model is ready, right? Which you can use further. Yeah, please, someone raise the hand. You may please ask.
Thanks, Doctor. I wanted to ask, maybe try and explain my question. Earlier on, when you said, when you asked whether it's the data that comes first or the model, I thought it would be the data, but you explained that sometimes the model already exists, but we haven't identified it, or we don't know about it, but data is used. So I wasn't sure whether data is used to detect that unidentified model, and therefore in future we have some form of data that will help us identify similar models, and maybe also identify models that are different from the ones that we already identified. I'm not sure if I still don't make sense.
Yeah, actually, you are right. When we have the data, so every data governs or comes by the different models, right? And we don't know which model is that. Right? So what we do, we try to build or rather estimate and model, right? Which is already existing, but we are not aware of it. So we tentatively prepare a model, we build up a model which is, we assume, which is approximately similar to the original model, right? And we say that it's 90% accurate, 95% accurate to the original model. And even in the practice, we get the 90% accuracy, 95% accuracy. Then that is much better than the anything else. So we use it. Now you say that when we have the another data, so can we use the same model or we have to build another model, right? You always have to identify if the data has the same assumptions, same patterns, same nomenclature, same metadata, in fact, then you can use the same model, right? Otherwise, again, you have to prepare the model according to the data which you have in your hand, and then perhaps you can use that.
Okay, which I assume could lead to us being able to predict models that we will get in future if we get the data combination correct for such models.
Yeah, if you are very sure that the data has the same characteristics, then the model which you have already prepared is good enough, right? But if those data can enable your model better, right? Maybe, I mean, as I said in the beginning, in the machine learning algorithm, as much data you feed them, that much better the model will become, right? So sometimes it may possible when you feed the data again, your model is now 1% better than the earlier one. So you always want to use that.
Thank you. Thank you very much, Doctor. I understand now. Thank you.
Thank you. Thank you. Hope I respond to your question.
Yes, you did respond to my question. Thank you very much, Doctor.
Now, so when I say the machine learning algorithm is basically to understand or ingest the data and run a model from the data, right? And based on those models, you have now to take the decisions. For example, if you are detecting the spam mails, right? Making predictions about the future data and taking a decisions, right? So how does it works? You can see a picture on your slides that there is a training data, right? So usually what happens, we whatever the data sets available to us, whatever the different data sets available to us, we just divide those data one into two parts, and one is the larger part, obviously, and another one is the smaller part. Maybe you can say 70% and 30%, and we train, right? When you say train, means you are estimating the model. So you train the model with the training data sets, which is 70% around, and then the remaining 30% data can be used to test, right? Those models, whether it is performing the same things or not. And why do we do this? Because we know the data sets which has the complete data of 100%, perhaps having the same characteristics, right? And therefore, we try to see whatever we build it as a model, does it perform the same same things? Does it gives you the same data when you are using that model or not, right? And since we have the test data, we can we can rectify, we can verify that whether we are getting the same data or not, which we were expecting with this model while estimating, right? The models which we use nowadays, if you remember, I don't know if you have come across the situations before 10 years, right, when we were using the Gmail, and now when you are using the Gmails, you will see that the mails which is not directly related to you, or maybe some fraud emails, maybe some ads emails, is comparatively less. Are you getting me? Yeah. It's comparatively less, right? What do you mean by drain? Drain, it's not a drain, it's a train, right? Training data. So when you are training to the models, that question was on the chat box. Okay. So, yeah, shall I continue?
Yes, sir.
Good. Thank you. So, yeah, so I was asking, so you can realize before 10 years, we were getting the lots of spam emails which were not related to the us in the inbox, right? And then now, if you see your inbox, you are getting comparatively very, very less emails. Why so? Because the spam recognizing algorithm has very, very strengthened as compared to the 10 years. Why? Because it has now the lots of data, right? And it, in the regular time intervals, it takes the feedback from you, feedback from users, in fact, that these emails are likely to be spam, right? Even nowadays, when we get a phone calls, right? When you have a phone calls, and majority of us use the true caller. So when we get the call, it shows you that it's a red color, numbers, or sometimes it shows you that the marketing calls, it's a fraud calls, it's a spam, right? So that is also the machine learning algorithm, which defines that this is, since it this calls has. And if you ask how does it happen, so you see the numbers, right? You see the numbers, one thing. Second thing, when you get the call, so you have an option to give the feedback that this call was the spam? Would you like to block it, right? Would you like to continue? And some of us give the feedbacks as well that yes, this was an spam. So when you give the feedback, it learns, the machine learns who recognizes the calls that this is a spam. And it has certain similar features like the numbers, like the originated place, number of calls made from these particular numbers, etc., etc. And based on these characteristics, they identify that this is a spam call or spam email and then put into that folders or features. And these rules, it's not static, rather than it's adaptive, right? It gets the data and strengthen the model better and better. And that's why I asked the mails which you used to get the spammers 10 years before, are you getting the same now? Definitely, the answer is no. We are not getting such amounts of emails as a spam now. Okay. So when you say how does it works, we were discussing in these directions. How does it works? In fact, right? So it takes the data, and based on the data, it gives you the idea, and rather than sometimes it takes the decisions even, right? You must have come across the system online challan, right? So in India, when we usually travel over the expressways, so there is a highest limit which is perhaps the 100 and 120, right? So the moment you cross the 100 and 120 speeds in the car, bike, truck, whatever, automatically you get the challan, right? Because the cameras are capturing your speeds, and based on the speeds they are trying to segregate into the two parts, right? So as you can see here on the screen, the linear classifier, one is above the certain speed and one is below the certain speed. So the moment you cross these speeds, automatically the challans created and sent on your mobile number, and you are able to understand. So these are the machine learning algorithms which we are seeing across our day-to-day life. So as I said, the good data, if your model is being trained with the good data means the data which has the lots of information about the similar types of data, and building the statistical model, definitely that models are going to perform better than as compared to the any other model which has not been trained by the good data, right? Now, if you would like to say some, some pictorial representations, right? Here you can say we have the one feature which is the nose size, right? And ear shapes. So based on the nose size and ear shapes, we are trying to classify the images into two parts. One is the, right? And please understand, this is not labeled, right? We will discuss this later, labeled and unlabeled. We have just given the photographs, right? So based on those photographs, the algorithm, right? They have prepared an algorithm of segregation, right? Of classification. So one set says which have the same or similar ear shapes and other features, and one set says that which have the nose size as big and the other features common. And you see that the it is very likely to segregate the two different species, right? One is the dog, another one is the cat, and you can segregate them into the the label whatever you want as per the requirement. In the similar way, let's suppose you have given the data of 10 years of data of the different cricket match played in by the BCCI or ICC, right? And you have just given the data to the machine learning algorithm. They will segregate if you are using the classification, two-way classifications. So they can segregate based on, let's suppose, those who have taken the wickets. Well, if you are using the two features that they run and the wickets, right? So they can classify the two things. One where the people have scored more, means they have prepared the good run, but the wickets are very less. And the another set, the wickets are high, but the runs are comparatively low. So then you can call the one set of people as a bowler, another set of people as a batsman, right? You have not labeled anything. This is being done based on the features available in the record. Similarly, now if you would like to predict anyone whether that person can be best suited to the as a bowler or as a batsman, the moment you input the features of that person, that player, it tells you that he suits as a bowler or he suits as a batsman, right? So this is the machine learning algorithm. How does it work? So this is the linear classifier. Another one is can be the probabilistic classifier, which can be used as a statistical model, right? Where the probability also plays an important role. We can see, on the later slides. Majority of the time, when we try to predict the certain things using the any of these algorithm or data, we focus on three things. One is the underfitting, overfitting, and balanced. There might be a certain debates which one is better, underfitting, overfitting, etc., etc. I won't go into that debate. We as a as a machine learning algorithm, or when we are preparing such algorithms or model, we always try to predict the better and better predictions as compared to the model and earlier data. We are not at all interested in the overfitting or underfitting, right? But if you think about this while showing this, this chart, my aim is just to make you understand. Even with if some model is very accurate, but it is very complex, right? And the another model is very easy, simple. Maybe it is not giving you the very accurate answer. right? That can be preferred over the complex one. That means if suppose you have done a prediction with an easier model, and that gives you 95% accuracy, right? And there is a simple model which gives you 93% of accuracy, 92% of accuracy. But that is much more simpler as compared to the another one, the complex one. You would always prefer the simpler one. Yes, Masi, you have some questions.
Thank you, Doctor. I wish you'd give examples of simple and complex models for my understanding. And my other question would be, what happens if maybe in your data you also have outliers?
Yeah, we'll come to that. So, complex model, a very simple example. Let's suppose you are using a 2 degrees of polynomial, right? And when you have a linear regression model. So when you use the 2 degrees of polynomial and the linear regression model, you will realize that the 2 degree, obviously it is not much complex, for example, but complex than the linear one. Okay. So if your linear model is able to predict, able to give you the accuracy around 90%, 92%, and your 2 degree polynomials gives you the 94% of accuracy, let's suppose, then I believe that the linear model is much advisable to use than the 2 degrees of model, 2 degrees of polynomials, right? Because when we use any of the model, estimate the model, then it takes up procedures for estimation and estimation of different coefficients, right? And it also incorporates the lots of errors which we are sometimes aware of it or unaware of it, which might be the measurement error, which might be the non-response error in the data, etc., etc. So it comes out. Your second question, if you have the outliers in the data, sometimes you have to recognize that what is the significance of those outlier. In majority of the time, your simple answer to your question, we should avoid the outlier, right? But I would recommend you to see what are those outliers, because you are the researcher, you are the practitioners into that particular case, into that particular environment where you're asking the questions. So you need to decide whether removing these outliers will affect your result, which is a meaningful, or whether just ignoring these outlier will give you the result, but it is significantly losing some information. So in that sense, I would just tell you the one line. You need to understand what exactly the outlier means, right? And if it's outlier, definitely you are sure, remove it. Right? Thank you. Okay. Now, as I said, so we are using the ML applications around us, right from starting from the day to the end of the day, right? Means from the morning to the evening night. So we have seen one very good example of this spam detections, right? All of us use the Gmails, and then we have the lots of spams emails, right? And I'm sure, I don't know whether you visit this spam folder or not, but I'm sure on a daily basis you get the more email as a spam than your regular emails, right? All of us. So you now can understand, and believe me, you saw on the first slide that 45% of the emails are, spam. The total emails which you receive, it's really very, very true. Right? You can have a look on that. Okay. After that, we have the different, the gadgets which can take our voice and perform certain kind of task which we have now see with the help of the Alexa and other devices enabled in our home or offices. Second, now if we use Amazon, Flipkart, Netflix, YouTube, Facebook, etc., etc., this shows you lots of different features, lots of different things. Because in the marketing now, customer segmentation is a very, very prominent areas where every, every at least social platforms, social, media, social selling platforms would like to dig that, right? So they need a customer segmentation, which is perhaps based on the machine learning. And then after this segmentation, they would like to show you the product which is meant for the specific segment of the people. And please understand, this segment of people is not the mutually exclusive, right? It's overlapping. So, for example, the moment you buy a formal search on Amazon, right? On the different, on the second incidence, they show you the formal pants, formal belt, formal shoes, ties, etc., etc. Why? Because they know if you have taken a cert, formal certs, possibly you will use those formal certs in the meeting, parties, anywhere, right? And at the same time, you need the formal pant, belt, ties, etc., etc. So this is the recommendation system which is used by a different social platforms, right? Now they also would try to understand that which feature has to be shown first. Means if you have taken a cert, what is to be shown first to you after buying a cert? So whether it should be the pant, whether it should be the belt, whether it should be the formal shoes, whether it should be the blazer, etc., etc., right? And that also depends on the data as well as the machine learning models. So that means, for example, I purchased a laptop. On the very second moment, they will push you, right? I use the word push you to buy the laptop protective screen, right? The keyboard protector, the soft pouch to keep your laptops, the wireless mouse, etc., etc., right? Why? Because majority of the people who purchase laptop just after the purchased or around those purchased, they have purchased the similar things, right? So then the customer hit and rate of the customer purchasing of these products, right, will put you into certain segmentations. And the moment you buy those products, they keep you out from those segmentation and put you into the some other segmentations. Whether maybe after few years you will also like to buy these similar products, right? So this kind of recommendation we are using in our day-to-day life. That's what I would like to mention here. In the in the medical field, you see nowadays the medical practitioner, right? The medical practitioners are using and relying on the machine learning models, and based on the machine learning models, right? They are trying to advise you. They are trying to give you the feedback. They are trying to give you the medicine. They are trying to uh, suggest you the tests which you require, etc. So initially in the medical field, the main aim is to know or measure the variations. So when you are able to record some of the variations of the, you know, some, some measurements like your blood sugar, blood pressure, heartbeat, right? Your other activities, right? So earlier as well, we were trying to measure these things and their variations, and then we say or consult with a doctor that this is my body temperature from last 2 days, and then they give you the medicine and the amount of medicine. The same thing is being done now by the gadgets, and now gadgets can also prescribe you the amount of the medicine as well as the medicine, right? So wherever the system is being automated, right? Similar automated, you may say, you don't need any person or decision makers, rather you can see these things. Definitely in the wherever the things are very, very crucial, same in the healthcare, you always need an advice and suggestions from a human being or human practitioners over than the any other these AI apps, because these are in the way of getting the things strengthened. They're not so far the powerful to suggest you and you can believe. Definitely after 10 years, maybe 10 years down the line, we will certainly believe on such apps, such recommendation, and we will follow them. Okay. So now this we use Alexa, we use our other instruments as well, which use the speech recognition model, and they work accordingly. Similarly, the online fraud, credit card return request, credit card fraud, such can be done with the help of the machine learning models, right? So you have the data, you run a model with the help of those data, it will give you certain classifications, right? Maybe certain, classifications, and then they will give you the idea whether you are in the segment of the fraud detections or you are in the segment of the means not a fraud detecting list. What do you need when you would like to prepare a modern machine learning models or algorithm? You need only two things, right? The data, the large amount of the data. When I say the data, you please understand is the good quality data. Good quality data means which has certain patterns, certain levels, certain existing understanding models. Understanding the features of the phenomenon which we are trying to establish the model or discussing here. One, right? Second thing, you need a very, very good computer which can process those data, because now it is the era of the big data, right? And processing of big data is very difficult or not possible with the help of the old machines, right? Which is we are calling as CPU, now we are calling it as GPUs, right? So you need a good amount of the data and good computing power, right? If you have these two things, you are able to prepare the model, work with the model, establishing the model, etc. etc. Now you will be surprised to see, as I said in the beginning, that these models perhaps the new, but these algorithms, these techniques are the older one, which we were using long ago and which we have used long ago into the different stages, right? But at that point of time, we were not, I believe, we were not generating the amount of data which we are generating now. We didn't have the smartphones, which is one of the major sources of generating the data. We didn't have the smart watches. We didn't have the smart TVs, right? So at that point of time, we are very, very limited with the sense of the data or availability of the data. Now we have lots of data, and therefore such algorithm which were existing earlier but not given a due respect at that point of time are working progressively in this era, right? So if you see here, then in 1750 to 19, people were talking about, the Bayes theorems, and they developed in the Bayes theorems, and then they, taught the different methods with respect to the Bayes theorem. The same is being used now as an algorithm called naive Bayes, right? So you see, we have developed the same thing, the same concept which people are using now into around 1800 century. To 1950, 19 to 1950, we have the PCAs, we have the factor analysis, we have the CCA by modeling, and exploratory data analysis. We also had the discriminant analysis at that point of time, right? And we all have used such techniques for the prediction, which was already existing. So in the same manner, if you see the era from 1900 to the 2020, right? All of us are using the machine learning models and the different algorithms to make our decision better. In the last, there is written as AI winter. What do you mean by this AI winter? Anybody? Anybody knows about AI winter? No? Okay. AI winter is the period where the artificial intelligence or machine learning has not progressively improved as compared to the earlier. Right. So you may say this is the stage where the use of the AI is people trying to reduce as compared to the earlier time. Right. That is the AI window. This is the development of the deep learning, how we have, started the development of the deep learning. Yes, Mercy, you're
What could
welcome
be
to
the
ask.
cause? What could be the cause of the AI winter, Doctor?
I am not sure the very specific causes of the AI winters, but the I must say the ethical concern, one of the major major cause of this AI winters, right?
Okay. Okay. Thank you.
Yeah. So this is the deep learning. Okay, yeah, here. So deep learning developments from 1940 to 2010, right? And it has the several stages, different scientists, statisticians, mathematicians, computer scientists, physicists have worked, given their valuable time to develop these techniques here, which we are using nowadays. So ML here impacting our daily life, as I said, from right from the beginning to this one. So we use the smart watch, we use the smart uh, gadgets to even wake up. Then we use the uh, you know uh, maps, Google Maps, to reach to the destinations. We go office, we reach office, then we scan our fingerprints, scan our faces to get an enter, etc., etc. Then we, whatever you buy, whatever you eat, whatever you, wherever you goes, right? All those places are enabled by the machine learning. Even when you would like to see the movies, so they suggest you what movies you are supposed to see. That is the algorithm based on your data which you are giving here, right? And that's what I said in the beginning once, that the all those things which you are which is problematic for you is generated by yourself. You know, sometimes maybe I realize that they are using your mind, they are using the way how you think, they are using the way how you behave. After a few years, maybe they can predict the password which you have stored for your Gmail account, for your credit cards, uh, for your debit card, isn't it? Don't you think like that? Is it possible? Yeah. Yes. So, so you see that the things which we are using into our day-to-day life, how dangerous it is. And nobody else is responsible for that. We are only the responsible. Maybe this might be the another cause of the AI winter, right? And definitely we are not ethical. We share the data, with the other parties. Like you say, you have the fraud calls, you have the different calls to get some amount to be transferred here and there from your bank account. And you will be surprisingly see nowadays, I just realized all of us use the two mobile numbers, majority of us even use. You always get a call on the number which is connected with your bank. I don't know whether you have realized or not, right? So that means they have the record that which number is being associated with your mobile bank. And don't be even surprised to know that they know how much amount is there into your bank. Right? So these are the concern when we are generating the data, when we are sharing the data, right? And after that, definitely the ethical concern which comes in, right, uh, into the data privacy and uh, life life cycle of a data. Actually, we have the very, very specific life cycles of the digital data, but we don't follow, right? We don't follow, and even sometimes we don't know what is the life cycles of the digital data. So that is the problem, and maybe the cause of the AI winters into it. Okay, fine. Uh, yeah. So, wherever we develop the model, right, we do not try to do a things or prepare a model where the complexity is not very high. Yes. So, for examples, detecting spelling mistake, right? Not a good ML problems. So you don't want to make an model which can only detect a spelling mistake. Right? You always want to get a model or prepare a model which correct the spelling mistakes, right? And that's why if you when you write the words, when you write the emails, etc., etc., right, the Google suggests you the right spelling. They tells you first that this is not the correct one, or in fact that they Google feel that this is not the correct one, maybe it is correct. And then when you right click and make it on that, this can be become a you can rectify and make the possible one, right? When to apply a machine learning model is a very, very specific and very, very correct questions. So when the people are using the Tesla car that is prepared, and it works in the US and UK's in the New York City, what do you think? Can we use the same car in Delhi, Chandni Chowk, into very busiest areas or any such areas which is available in these photographs? Can we use those things here? Yeah, obviously, someone can debate on this, but I feel it's very, very difficult when you are trying to implement those things here, specifically when you see such situations into your photographs. So might be when certain things are meant very, very specifically with respect to the applications, with respect to the, you know, data, we can use it, right? And therefore, it will, since it's establishing the model, right? Establishing the model, it will take lots of time to uh, get it done into these situations. Fine. So whenever we use the machine learning with respect to the other techniques, it becomes a new applications of the machine learning. Maybe machine learning with the programming languages, so they can correct the, programming languages, and they can give you the correct understanding, correct programs with what you are supposed to write. The earth science, video processing, image processing, etc., etc., right? And they can use it. Now, the machine learning is specifically using a very good things, which is a real time language processing, right? So you can directly talk to the people, even if he is not able to understand any specific languages, maybe English, Hindi, Spanish, Japanese, etc. So that the real line conversion. Even nowadays, when we walk around or travel around the globe, we see the translator, the Google Translator. So it's a real-time translator which just see and translate to your preferred languages which you have already filled in, right? You may not have been asked, but they can give you the right things into your language, because they know that you understand Hindi or English, and accordingly they convert and give you some things. Some success stories in terms of image restorations can be an applications of the machine learning. So you can see the old image, and there are new images which has been built. Some image recognitions, if the image is not being very, very clear, or it is being turned, or some parts of this image is missing, so you can just get a idea about the images. This is that's what I was saying, you the computer program, that's we could say. So if you see, uh, if you are aware about the C++ languages, you will be able to understand this programs. So you see that there is a A, but it recognizes that it should not be the A, rather than it should be the ampersand A, which can understand and read the meaning of the ampersand. Right. Similarly, you can use and create the better images if the images are not very clear. So you can, with the help of this machine learning and feature recognitions, you can make the images better. Obviously, the ML is not a very, very fruitful always, right? Rather than you have to see, it's not always the thing, or it's not always the question that the ML is working, right? ML is working. Rather, you have to be focused in many of the things that it is fair and unbiased over the time. Specifically, when you're talking about the healthcare, when you're talking about the human life, when you're talking about the financial sectors, when you're talking about the laws, you have to be more focused on the fairness and unbiasedness in the decision making, rather than only the data gives you in and you get something out, right? One person asked a question on the chat box, how to prepare a good ML model. I'll tell you in the last, right? Let me just uh, cover up the things, and definitely we'll see that. So, in the whenever we prepare any machine learning algorithms, right, it is like the exams. It does not important how well you have prepared your model, or in fact it is, but that can be measured on the output, what you receive after the applying the model, right? How does it behave with respect to the test data rather than the training data? Definitely, when you are training the model, right, you have some of the measurements which can tell you how accurate your model is. But when you are trying to generalize your model or generalize the performance of your model, then it is very important how does it behave with the test data. And if it is working good with respect to the test data, as well as the fairness and the unbiasedness which you need into your model, then definitely your model is the best one, right? And how does it works? So you give them some, tests, some data, some practices, etc., etc., right? This is obviously a human being exams, no, not a ML. So you study, give them some tests, give them some study materials, test papers. Based on that, you prepared something. Based on that, what you have prepared, you got some of the knowledge about the subjects, and then you are giving an exams, right? Right? And then based on that, you have passed or failed. Good. And then you have to give the actual exams to understand the subject knowledge. The same works here in the ML as well. So the model stores, when you give the data to the model stores the data pattern, use the model to predict on the test data, critically see and recognize, segregate the test data, then they, you know, try to check the accuracies between the training and the testing data, whether are they similar or not, and then they should test the data, right? Means they should train the data again, in fact, if they are not good, with respect to the or without actually, uh, seeing the test data. And the similar things is here with the human perspectives, as I said in the exams examples, right? Now, if we talk about the types of the machine learning, right? So there are three machine learning types, right? Please understand, these are not the uh, algorithms, these are the different types of learnings. And under that, there are the different algorithms to perform the similar learnings. So supervised learning, unsupervised learning, and the reinforcement learning are the three. Sometimes people also add a one, which is semi-supervised learning, but that is not required, I believe. So when you say the supervised learning, right, that means you have to be supervised, right? And how will you supervise? That you will give something as a label to the machine, right? And then you will try to see how machine behaves on it. Okay. So, for example, if you are showing a machine an image of apple and you are labeling that image with the apple, right? Later on, whatever image you will give of this similar type, machine will tell you that this is an apple, and you are supervising means you can give them a feedback, yes, this is right. Right? Similarly, we work on the different uh, machine learning algorithms as a supervised learning. Can you give me any real life examples where you feel the supervised learning procedure is working? Any example?
ATM machine.
How does it give you the example of the supervised learning?
Sir, as we know, when we put the card, they come the commands. When you cache the withdraw, the algorithm says how to withdraw the cash. Yes,
Okay.
deposit the. They pre-planned commands. They does not read from their existing command.
Okay. Okay. Any other examples? Have you come across a feature in the Facebook that a face tagging? So when you upload some of the images, Facebook tag those images by themselves, right? Have you come across any such feature?
I'm not using Facebook, sir.
Okay, good. So when we use the Facebook, or even the Instagram, so whenever we put some of the images, they ask you to tag your friend and they suggest you, while seeing the faces, they suggest you the name of your friends to be tagged. Only thing you have to confirm, right? That is one of the feature of the supervised learning because they know they have your images, they have your names, right? Names means the names which you have created on your Facebook. And based on that, they would like to tag you, right? This is the machine. It is looking with the help of the machine that whatever name you have given into your Facebook profile, yeah, whatever name you have given to your Facebook profile or the Google profile, they tag the same, even if your name is something else, right? So that is the machine and the one of the examples of the supervised learning. So classification, regression, rankings is the other different algorithm used at the different places under the supervised learning. Right? So you give the label, right, and you know what is the output, and machine is the learner explicitly with respect to that images or that label which you have given to them. On the other hand, you have the unsupervised learning, right? Whether you don't need to give any kind of label to that machine, that model, right? It learns from themselves. So as I've given the examples in the beginning that if you if you give the characteristics or if you just give the record of the 10 years of players who played the World Cup, etc., then they can segregate easily that who are the bowlers and who are the batsmen. And later on, they can predict about anyone who is the bowler and who is the batsman. If you would like to prepare or you would like to give the profiles, those who are bowler as well as the batsman, we call it as all-rounder. So they can also predict you that the distances from the bowler and the distances from the batsman are the quite similar. So this must be a person called the all-rounder, which you can label later on the all-rounder, but this can do both well. That can suggest the machine. So, and the algorithm for doing this is the clustering. So whenever you give some of the data, some of the sets of the data, in fact, they will segregate the data into the different clusters and they can, based on their, definitely based on their characteristics. And then whenever you ask later on, they will tell you that this person or this set of data comes in which cluster. So accordingly, you can predict the same. In this, clustering is most famous, easiest way of segregating the data. After that, dimensional reductions, probability density estimations, etc., can also be a part of this algorithm. The next one is the reinforcements learning. Right? Whether you don't give a label, right? And you even, doesn't remain it unlabeled in the traditional sense, as you see it's written in this slide. So what you are doing here, you are just giving you the feedback, or you made a mechanism where the feedback can be given to this kind of decision making, right? So whatever decision making is being done, the feedback is to be given. Can you come across any real life of examples in the reinforcement learning? Anyone? Can you just tell me if you have come across, or if you something is in your mind as a very, very real life basic examples of reinforcement learning? Self-driving car. Yes, self-driving car. Tesla is the reinforcement learning cars, definitely. Right. I'm just asking a real life of examples in the reinforcement learning. These are the artificial examples, right, which we made by ourselves. No? Okay. Uh, if you have seen a newborn baby, not a newborn, but the around 2 years, 1.5 years of baby, and you put the candle in front of him, right? If this is the first time he has seen the candle, or she has seen the candle, she will definitely try to touch it. And the moment she touch, she will be hurt, or he will be hurt, right? So that's the first time she is trying to touch to the candle, inflate the flame of that candle. And she got the feedback that she can get hurt. Nobody tells her, right? And even tells that she might not be able to understand at this age. But you will see surprisingly that she will never touch that candle again. And not only the candle, they will never touch a things which is getting the same flame. Do you agree with me? Yeah.
Yes, sir.
That is the very, very real life of example which I have realized at my home. So I have a very small baby, so I realized that this is the self reinforcement, which tells yourself that this is right or wrong. And even not this is right or wrong, you will never perform a similar kind of task again, or just similar things again. You must have played a chess, online chess, online FIFA World Cup, online online in such games, which is also nowadays based on the reinforcement learning, right? You will never come across this, but you can realize first thing that you will never be easily beaten to the computers, right? Let's suppose we are talking about the chess. Second thing, you can, even if win with respect to the your game, the again computers against the computer, you can never win the game against the computer in the same way, in this similar way, because he gets the feedback. He played those steps and he loses the game. So he just understood that I don't have to again use such a steps, right? That is again the reinforcement learning which you realize. And the best thing of this reinforcement learning is that it keeps on updating, which is not explicitly available in the supervised or unsupervised. Right? So this is how does it works. As I said, it gives you the label and then training data. So with the help of the training data, we have extracted some of the features, different features from different images, and then we try to compare that which one is the dog, which one is the cat, and we store those features. So whenever we get the another images, we try to compare those features, and after those comparison of those features, we label that whether it's a dog or whether it's a cat, and then we come across to the final decisions with the cat or dog. In unsupervised learning, we don't have the labeled data, we have the unlabeled data. And since we have the unlabeled data, it's get the feature extractions and then divide into the two parts. Now, these two parts has to be labeled by ourselves, right? So you label them later on that these are the cats, these are the dogs, and the same is being remembered by the system, the model, and later on, they can predict you for you whatever images you send them, whether that's a cat, whether that's a dog, right? Right. We may have also not only the two, we may have the three, four, and whatever you want can be the feature, can be the clusters, right? So for example, here it's a two based on the cat and dog, we may have the certain modes, and that is the examples of the clustering. Similarly, the examples of the typical reinforcements learning, right? How does it work? You can see this, I don't know, and you remember that this is the game of the Mario's, right? We have played into our childhood, possibly. So this is the observations, and that is the reward state, right? And then there is a action. So whenever you know, they get a feedback as whether they have won the game, whether they have lose the games, etc. And that is where they are trying to improve themselves. So as I've given the examples of the chess or football, World Cup, FIFA, certain things like that, you can improve by them with the help of this implicit feedbacks, right? And this is one of the feature of improving with the help of the feedback is not present in the any other two kind of the learning procedures, which is explicitly here, right? So that is very, very important and attractive in this manner. If you talk about the some geometric perspective of machine learning, right? So you can give the inputs to the ML problems, which can be often represented as the points or vectors or the data sets, right? And after that, you can see the images here, which works with respect to the geometric perspective here. And for example, if you are trying to see the regression, right, and the regression is a supervised learning problem. Goal is to model the relationship between X and Y, which is a real value output, and the akin to a line or the curve fitting problem, right? So you can see that these are the line which puts you here, and these are the points. If it is looks like this, the linear one can be a good one. If it is looks like that, then the curvilinear one would be the better. The another technique is the classification when we have two set classification, three set classifications, linear, non-linear, etc., etc., multi-rate classifications that can be done with the help of this classification. Right? These are the supervised learning. Right? The unsupervised learning is the the clustering is one of the approach and dimensional reduction is one of the approach, and on your slides you are able to see that the differences, right? So you see very interesting question that clustering look like the classification. Is there any differences? Yes, the difference is that in the clustering, the things are not labeled, whereas in the classification, those things are labeled, right? And as you know, that is the basic difference between the supervised learning and the unsupervised learning too. Dimensional detection is a very good concept with respect to the unsupervised learning and in the statistics too, because you always want to reduce the data without losing the information, right? So if you can, for example, we need to find the mean, we need to find the medians, etc. This is the in the layman languages, this is similar of the dimension reduction in a sense that if we can have the same information when we are producing a bunch of data, and if we are transferring the same information when we are only transferring the two data points or one data points, that is similar. So definitely it is much advisable, much easier to transfer the two values, two data points as compared to the set of data, right? That's why these things are very, very interesting here. Okay, what is that? So if you see as a functions, right? Right. If you see as a function with respect to the supervised learning. So what happened? You have something as a data you have given to the model, and they can give you the some of the classes or some of the classifications, right? In the unsupervised learning, we can also understand it's as a sum of the functions which maps each input to a compact representations, right? So we have some of the unlabeled data which do not have any label. We process through the model of unsupervised learning, machine learning models. And then we have the images, which is the latent representations of the images, right? And similarly, since it doesn't have any of the images, so as a complexity is it's the tough model, right? But as an application, it's a very, very realistic and applicable one. Now, if you try to convert this as in terms of the probability, right? In the supervised learning, we are trying to see what is the probability of the given label that it's a cat when any such images are given. Okay? Whereas in the unsupervised learning, you are trying to know the probability of that image. And here, the decision making is based on the probability density of the inputs, right? Rather than any label or any feature labels, because label is not available here. And we are trying to understand the distribution of this underlying data distributions and unlabeled inputs, right? And then we try to predict the image. Reinforcement learning is also, you can see in terms of the probability estimation as the estimation of the probabilities density, right? So for example, right, we have the data and the features. So different data have the different features. And based on that, we try to use the algorithm as a real, real practitioners or real world. So we just see with the help of this example here, to get the better understanding of this scenario. So ML algorithm requires a numeric feature representations of the inputs, and features are semantic of the inputs which can extract the good features to prepare the better model. Features can be obtained with the two approaches: one, extracting, constructing features manually from raw inputs; second, learning the features from raw inputs. So two approaches are there. One approach is that which we'll see here. Second is what it follows in the deep learning algorithm. Definitely, one is not as powerful as approach two, but is still used widely because of certain restrictions, certain constraints. We'll just wait. So there's a numerical features which can have the stars, right? For let's say the likeness or unlikeness. We can have the categorical features like blood groups, right? We have relational features like social medias. We have ordinal features as the ranking in the class. So these are nothing but the numeric data, ordinal data, interval data, and the ratio data, right? These can be the types of features which can be used to predict the data. Whatever you are giving the as an input, they are trying to predict the output, right? For examples, what are features? So feature as a way for us to give an input to the ML algorithm. Most ML algorithms use numerical vectors to represent the features. For example, in spam classification, every old email as well as the new email, means the training data and the testing data, must be converted into a vector, right? So you can see these are the vectors. So do you want to go for a dinner, right? Suppose this is a email which you received, and you have given some features as 0 and some features as 1. Possibly the 1 is which you can treat as the correct one. Correct one means you don't have any problem with such features if this is in your email. But if there are features like currency, there are features like transfer money, there are features like bank account, right? If these terms occurs into your spams, that this will give you the 0 as the feature restrictions, and other words can be taken as 1. Similarly, do you want to win $1 million? Right. So you can see that these have the 3 zeros in the second one, right? So in the same way, they try to get the features, right? They have given here, those numbers are there. So million was there. So they have given $1 is there. So they've given as one, right? This means that there is a word present which says that million and the dollar. And with the help of this yes, right? With the help of this yes, with respect to the million and dollar, they recognize that this could be a spam email. And already in the past, many people have put such emails as a spam, and they are confirming yes, such emails are the spam emails, right? Therefore, without asking, now they can realize with very higher accuracy, the model, that this is a spam email, and let's put this email into the spam, right? Rather than this, sometimes you believe, sometimes you come across that emails are good enough, right? But the email ID is suspicious, and therefore that particular emails went into the spam, right? So this is the way how can we convert this into this feature. Okay. There's a questions, which she asked, why did we not keep the word to as a feature, right? You see here, there's a word to, right? So they have not taken that to as a feature. Why? Because that is not the one of the feature which can be segregate an email as an spam or not spam. Or in other words, that's a simple word, right? Like of, to, the, right? So these are the simple words which can be available into any of the emails and has not any contribution in recognizing or detecting an email as a spam or not, right? Similarly, you see the do, right? This do have the different meaning in this 3 emails, right? And therefore, it should also not used as a feature extraction, right? So that is thus an example. The another examples in this case, I am skipping this one now because of the time constraint. I'll share this PPT with you so that you can have the, you know, you can have this PPT and you can go through it and ask or clear your
Complete
doubts.
हो गया ना?
As an acknowledgement, I would like to acknowledge the few peoples, Dr. Tanvi Chakravarti, the ISI professors, right, with the help of whom I prepared these slides and understood the concepts of this machine learning earlier, right? And now I am available to give your answers of your questions which you ask in between, right? So if you can re-ask your questions, or maybe you can unmute yourself and ask the questions directly. It would be good for me to answer the questions now.
Excuse me, sir. Hello, sir. Am I audible, sir?
Sir, yes, you are audible. Sir, please unmute yourself. Dr. Prayas, sir.
Yeah, please. You are.
About the assignment of weights to the data, you said we have to get it from the previous experience. Whenever we start doing the research for the first time, if I want to convert my research in machine learning, if I don't have any previous experience with the data, how to assign the weight then, sir?
You don't have the previous experience with the data. What does it mean? The data is not available in that regard, or you are not exposed to those data.
It is not like I have already done the experience or the experiments with the machine learning. I'm doing research in fluid dynamics. So I have a set of data. I want to convert it in machine learning. I want to extract the model, for example. So I may not have any previous experience with my data. When assigning weight to the data during the training or learning process, you said from the previous experience only we have to assign the weight. If I don't have any previous experience with my data, how to start with assigning weights initially?
No, the weights, assigning the weights is one of the process in the deep learning procedures where you are using some neural network algorithms. In the simple machine learning, or suppose, regression, right? So you have the data, whatever data you have, you just segregate the data into two parts, let's say 70% of the data and 30% of the data. See which model works. Like, for example, I assume it's a regression, right? Use the regression model, get the values of the coefficient. Now, as you have the values of the coefficients, you have your model ready. So like, for example, y is equal to 2 plus 3x, right? So let's suppose x is the height and y is the weight, right? So now your model is ready and you can use any of these features for training the model. Training the model means for estimating the values of the coefficient. So once you have this model, right, this is y is equal to 2 plus 3x, the remaining 30% of the data can be tested on this model. And you can see that the weight which you are giving as x, does it produce the same value of y which is available into your data, or how much it deviates, right? So that means you have now prepared the model, and based on the model you can use the predictions for the longer run or for the similar set of data. Hope it's
Okay.
clear.
Yeah, sir. Thank you.
Thank you.
Sir, there is question some chat box. Dr.
Okay.
Gaurav Kumar. If we train and test our data set through any CNN transfer learning, any model, can we attain 99.99% accuracy? Many
No.
research papers got rejected by reviewers due to this issue. Your input, sir, please.
See, 99.9% accuracy means the same model, right? And practically speaking, we can never get the same model which, which is the data is being governed from. So the answer to your question, we can never get these kind of accuracies in any of the practical researches. In fact, if you are working in the field of social sciences and management, your accuracy will be around 70, 75, and that is treated as the good accuracy, because this accuracy differs from situation to situations, from field to field, right? So when you are doing something in the science, let's suppose the experimental research, right? Physics, chemistry, where the experimental research has been done, you will always get the higher accuracy, right? But whenever you are working with respect to the social sciences, behavioral sciences, your accuracy will always be less than that. But that accuracy will be a good one from the another as compared to the other fields.
Thank you, sir. There is one more question in the chat box. How from Ibrahim? How should I convert an English statement into numerical value in machine learning algorithm?
See, this you need not to do by yourself. For example, I have shown in the slides. Otherwise, that will be done by the computer softwares, whatever you are using, it will be done. What we have done here, and I showed as an example, we have taken the three statements, right? And with the help of these three statements, we put wherever the words was present, we put it as one. Wherever those words were not available, we put it as zero, right? So when then the words were one, computer is able to understand that this particular email, because computer only understand the language of 0 and 1, right? It doesn't understand the English, Hindi, Japanese, Spanish, nothing, right? They only understand 0 and 1. So the algorithm or the computers understand that this particular email has the some ones which is denoting to a suspicious things, right? And therefore it has to be taken as a spam email. Hope it's clear.
Sir, there is no more question in chat box. So
Yeah.
now we conclude our session.
Please feel free if any one of you have any of the questions, I'll be able to respond. Or if you'd like to add some things to this session which can be fruitful for the other participants, please do it.
I think there is no more queries, sir.
Fine. So I
Now
hope
we conclude this.
yeah. So I hope
With
I have responded to all those questions which were there. If not, you have my contact numbers, email IDs. You may contact me wherever you want in this regard. Thank you. You are such a nice participants, right? And for your patient hearing. Thank you.
so give me a minute, sir. With the permission of organizing committee and chairperson, Dr. R.S. Gupta, sir, I would like to thank Dr. Prayas Sharma, sir, for sharing your knowledge and expertise based on machine learning. In today's session, Prayas, sir, start with the introduction of AI, ML, and deep learning, then continue with how to machine learning work, type of fittings in data, real life use of ML, how ML input our daily life. In the last, sir, tell us some success stories with the risk and sensitive problem regarding ML, taxonomy of ML, geometrical representation of ML. The whole session is very interactful. Thank you, sir, for such wonderful session. Now I would like to present a memento to sir as token of appreciation as well as love. Give me a minute, sir. I hope my screen is visible to you, sir.
Yes, yes, the screen is visible. The screen is
Sir,
visible.
please accept this token of appreciation and love for us, from us, sir.
Thank you, thank you, thank you. Such a nice one. So I'll get this as a PDF
Finally,
of
I would
some.
like to thank all of you for attending this session. Your participation and engagement have been greatly appreciated. As we come to end of this session, we would like to express our gratitude to all the participants for their active participation. We hope that this program has been very informative and beneficial to you, and that you will continue to apply the learnings in your work. We wish you all the best in future endeavors. Tomorrow we will meet at the same time for the next session. Thank you all and have a great day. Thank you.
Thank you, sir.
Thank you for giving me this opportunity and interacting with this learned participant and all of you. Thank you.
Participant, you may leave now.